There is actually one more way for testing association if there is association between two qualitative variables, which is called relative risk. Relative risk works only if you have two levels in each qualitative variables. Usually, relative risk is quite popular in medicine and biology, where one of the qualitative variable is a group, for example, those who take a medicine and those who do not take a medicine. And then the second variable, it's an event, for example, those who got this particular disease cured and those who didn't. Okay, you can think about some other examples. For example, the group can be those who attend seminars on statistics and those who don't attend, and the event will be, for example, those who failed the exam and those who don't. Okay, so the relative risk is the following. First of all, you calculate a ratio for for both events. So you calculate a ratio for the event occurred if you are exposed, event occurred if you are not exposed. And that's how to calculate this. Okay, so it's in fact it's a sort of proportion, right? And then the relative risk is simply the ratio between these two. Okay, so it's for example. The relative risk that you will not pass the exam if you do not attend the seminar. So what it means, you have to calculate how many of people did not pass the exam from those who attended the seminar, how many of people did not pass the exam from those who did not attend the seminar, and then take a ratio, Okay. So the relative risk, it's simply a ratio between the chances that particular event is occurred in the exposed group and probability for this event to be occurred in the unexposed group. Okay, so in this case, of course, we don't work with chances, we don't work with probabilities, it's a sample, so we work with frequencies with the proportions. Okay, let me show you some example. Let's say we would like to, we have a medicine that treats some disease. And then one of the side effects, we have some suspicion that this medicine also gives a migraine. Migraine, it's a terrible headache that people can have. Okay, so we would like to find out if a particular medicine indeed has a migraine as a side effect. Okay, and then we had 50 patients in each of the group. So 50 patients who got medicine A and 50 patients who got medicine B. And then we, after a while, we asked them if they got a migraine or not. And we found out that actually those who get a medicine B, 15 out of 50 got the migraine and 35 didn't. And then if you look at the medicine B, only 5 out of 50 got the migraine and 45 didn't. Okay, so now we can calculate the proportions. So the proportion of people who got the migraine in the first group is 30%. So 30% of people got the migraine. 30% of those patients who got medicine A got the migraine. Okay, then the proportion for the second treatment for the second group, it's 10%. So the relative risk in this case, it's 3. So it means that if you take a medicine A, you have 3 times larger risk to get a migraine than if you don't take the medicine A, okay, or take a medicine B. Or you can calculate also it's vice versa, the relative risk to get a migraine if you have a medicine B instead of medicine A. So in this case, it's 0.33. So you have 3 times less risk to get the migraine. Okay, so that's a very simple thing, as you see. However, you remember that all the values we got, it's only for our sample. So the relative risk 3, it's only for those 100 persons that we used 50-50 in 2 groups. Can we calculate, can we make some inference? Well, of course we can. And we know that we can use a parametric approach, so we need to know how the relative risk is distributed for the samples. If you take a lot of samples, what will be the distribution for the relative risk? Okay. And then if we know the distribution, we can compute the parameters for this distribution and then either calculate confidence intervals or make a test or do both. Okay. And in this case, of course, we don't have any risk. We don't have any difference. We don't see any difference if relative risk is 1, right? So the closer relative risk to 1, the less chance that we will see any difference. Now, the problem is that the relative risk itself is not doesn't have any distribution. However, if we take a logarithm of the relative risk, then the distribution will be approximately normal. So we can use normal distribution. In this case, the average will be the value, this value, the logarithm of relative risk, and the variance is calculated using these formulas. Okay. So and then you can calculate confidence interval, or you can calculate the z-value and make a test. I will show you only how to calculate confidence interval. I think you are experienced enough to find out how to calculate z-value and make a test in this case. Okay. Well, and in this case, the idea is similar to what we used for correlation. You remember that correlation itself doesn't follow any theoretical distribution, so we use special statistic, found confidence interval for this statistic, and then recalculated them back for the correlation. So we use the same idea here. First of all, we find a confidence interval using this logarithm of the relative risk. So we will get the two value, the smallest possible logarithm of the relative risk and the largest possible logarithm of the relative. And then we can use the inverse function. In this case, the inverse for logarithm is exponential function. We can use exponential function to calculate the confidence interval for relative risk itself. Okay. Let me show you how to do it. We will take the first case, the case that we discussed just recently with relative risk 3, and let's try to calculate the confidence interval. Well, first of all, we need to find the logarithm. Logarithm of 3 is 1.1. Then we calculate the standard, the variance in this case, and it's simple. You just need to know the formula. Okay, so the standard deviation, the variance for this particular case is 0.227. Okay, then you remember that the standard deviation is just the square root of the variance, so that's the standard deviation for our case. And now we can compute the confidence intervals, right? So just 1.1, it's average, plus minus 196 of standard deviations, right? So 196, it means that we calculated for 95% confidence, okay? And then if we take just exponential function for these two values, 1.1 minus 1.96 times 0.476, then we will get this one. Then if we do the same for the plus, then we will get this one. So this is E in 1.1 minus 196 times 0.476. And this value is exponential 1.1 plus 196 times 0.476. Okay, so that's the relative risk. So with 95% confidence, the relative risk to get a migraine if you use medicine A instead of medicine B is between 118 and 7.63. So it means that we see a difference, right? The difference can be as small as 118 or as large as 7.63. We don't know the real one, but it's somewhere in between. Okay. And then as any confidence intervals, they depend on the sample size. So if you take a larger sample size, in this case I have 100 people in each group, so 200 people in total, then the relative risk is the same and the proportions are the same. Then if we do the same calculations, you can see that the standard deviation is a bit smaller, and therefore the confidence interval will be a bit more narrow, right? So now it's between 1.5 and 5, somewhere in between. So that's the expected relative risk to get a migraine if you use medicine A instead of medicine B.